Hi everybody, this is John Fellenstein, also known as Professor Polymer, with today's daily demonstration. Today we are looking at the differences between two polymeric materials. One is called a thermoplastic and another is called a thermoset. Now remember, polymers are materials made up of long chains of repeating units. These repeating units are known as monomers. The long chain structure of polymers makes them useful in many varied applications. Plastic materials can be divided into two groups. Thermoplastic materials are the ones you are most familiar with. If we look at the term more closely, this is what you see. Thermo means heat, and plastic means moldable or formable. Thermoplastics can be molded with heat. Here's an example of a thermoplastic able to be molded at relatively low temperatures. We call this friendly plastic because it becomes moldable at around 60 degrees Celsius. Notice how the material changes as it heats up, becoming transparent. After we heat it, we have a few minutes to form it into the shape that we want. Thermoplastics start out as these little pellets that get heated up in a machine that pushes them into a mold. So these little pellets are called resin. What we're going to do now is heat up our friendly plastic in hot water. This water is hot enough to make tea. Here's our friendly plastic, and we're going to heat it up right now. Notice what happens to it as it gets hotter and gets to the point where we can perform our molding on it. Alrighty, see that? So now it's ready to form. Move this out of the way. Notice how stretchy it is. We have about 5 minutes to form that into something that we'd like to see. Okay. Let's say we form it into something and we don't like the way it turns out. What do you think I could do? I could reheat it and reprocess it and reform it again. That is correct. We're going to see if we can make a candy cane out of this. All right, it's still somewhat moldable, but notice the color is changing. And so it's becoming more translucent and more opaque as we mold it. There you go, that's a thermoplastic material right there. Now let's look at a thermoset material. The example I have for you is a two-part epoxy putty. This thermoset material is moldable, but we cannot reheat and reprocess this material the same way we can with thermoplastics. This is something that you can buy at a home store or even at Walmart. Alrighty, and it comes in a lot of different varieties. Thermoset plastics contain polymers that cross-link together during the curing process to form an irreversible chemical bond. The cross-linking process eliminates the risk of the product remelting when heat is applied, making thermosets ideal for high heat applications such as electronics and appliances. The primary physical difference is that thermoplastics can be remelted back into a liquid, whereas thermoset plastics always remain in a permanent solid state. Here we have the thermoset plastic right now. Notice that it's two different colors. So we're going to combine these colors, these two pieces together, and we're going to mix it up. We have to thoroughly mix this in order to get the material to cross-link and form our thermoset. So we're going to really mix that up. These gloves are giving me some issues, but that's okay. Now this is an exothermic process, meaning that the chemical reaction that is taking place in this material gives off heat. so it would feel a little bit warm to your touch. All right. A good analogy for thermoset plastics is if you were making a pancake. Once the batter is heated into a pancake, there's no way to turn it back into the batter. Thermosetting plastic uses heated molding techniques to shape plastic into permanent forms. Finished thermoset plastic parts cannot be melted and reused for other components. They retain their shape in extreme temperature and adverse weather conditions. Thermoplastics have a high strength to weight ratio as well. This property, combined with the ability to withstand very high temperatures, makes them ideal for many industrial uses. Here are the two candy canes that I made with the thermoplastic material and the thermoset material. The thermoset material needs almost an hour to cure, this one in particular, so it's not quite ready. The thermoplastic material, somewhat flexible. Thermoset material, not super flexible and very, very hard. Here's an example of a cube that I made another time out of a similar thermoset material. It's very hard and very, very lightweight and very strong. Well, there you have it. I hope you enjoyed today's daily demo on the difference between thermoset and thermoplastic materials. Have a great day.